Maybe if we get closer together.
He's calling me.
Be fine.
Web scale. Hey, I got an idea. Let me go backwards.
Web scale.
There you go. Yeah.
PHP.
How dare you?
Web scale.
No, you know what is web scale? Kotlin. That's gonna be amazing. It's good stuff. Hey, we're live from Kotlin Conf. I tricked 2 people into being on this live stream. They think we're gonna do a pre-recorded interview and it's gonna air after significant edits in a week. So hi.
Hi. We're
Hi.
live. We're live from
Yeah.
Kotlin Conf.
Yeah.
Yeah.
Okay.
I'm not a bottle of water. Sébastien Deleuze on the spring team. You've been on the show. I'm looking over here. I think my hand, you're on the right side in the picture, but you're on my left in real life. It's very confusing. Anyway,
They should mirror it.
yeah, totally.
Yeah.
My brain is not meant for this kind of stuff.
Yeah.
Okay, Sébastien, good to see you, my friend. You're on the spring team, and you're also one of the Knights of Kotlin. You know, like you know what a knight is. How do you say, say knight in French? I don't know.
Chevalier.
Yeah, okay.
I'm sure it's the right translation. And
Yeah, that's a cowboy too, right? Though.
Yeah.
Caballero in Spanish. Okay, and then of course, Google. Oh, hi. We're gonna do a live stream. You're welcome to be in it, but you're in it. Okay. Well, he was in it. So anyway, and then we've got James Ward, Kotlin product manager over at Google.
It is weird that it's not.
Yeah, it's not mirrored.
Yeah.
It's so confusing to me.
It is.
And
tripping my brain.
another thing that trips my brain out is Kotlin in any context besides the JVM. Now, this is one of the things that's kind of like really starting to heat up here. I meant to talk to him. It's one of the things that's really starting to heat up here at in the Kotlin world,
Mhm.
right? Because Kotlin it was born on the JVM.
Yeah.
But it's gotten better and better and better, and now it's Kotlin. There's a Kotlin multi-platform. We've all talked about that a lot in the last couple of years, I would think, right? It was officially because there used to be Kotlin JS, there still is, and that was a separate thing. And then there's Kotlin native, and there was a separate thing. And then at some point, more live stream. Okay. So anyway, there's all these different things, and then I think they got put under an umbrella, Kotlin multi-platform. Right, that was new. That was the unification of the platform.
Yeah.
When did that come out? Do we remember?
Oh, quite a long time, I think, but it has been through a lot of cycle of pre-alpha, alpha, experimental. I'm not sure, but it's getting. I think it's getting close to stable for mobile.
Right.
And outside of mobile, it takes a bit more time, but it's quite usable right now. I think that's.
So when you talk about mobile, but again, Kotlin has been it's dominant in Android, right? But you're not just talking about Android anymore. You're talking about like iOS. People are using Kotlin in iOS, and it's not just Kotlin native, right? You're talking about Kotlin and what is the other use case there?
Like the different backends for Kotlin multi-platform.
Is there an
iOS? You have Kotlin native, which can target native operating systems, so Windows, Mac, Linux. Can also target iOS.
Right.
And then you have Kotlin JS, which is targeting JavaScript. You have Kotlin WASM, the new kind of exciting new backend. And then you have what other backends? Any other backends?
I don't think we are good.
Isn't that enough? If you make any of those work as well as the Kotlin and the JVM does, you've got a winner.
Yeah, and one fun thing is that Kotlin native, there is this hierarchical multi-platform support where native has a lot of variant. I think there is 25 variant and more because it's using underneath LLVM, and that's also an issue for people doing native development because you need to. So you can write your common native code, and after you begin to put the variant for the watch, for the regular iOS, for etc. And it can be a bit tricky to manage, and also you need to create various compilation outputs, and that's where platforms like GVM, GS, or the new WASM platform, you have a single basically artifact to deploy,
right?
And life is simpler.
Yeah. Okay. Well, okay. So why couldn't it all just be WASM? And so let's talk about WASM. What is WASM? WASM, that's WebAssembly. I know what WebAssembly is because we are all constantly reminded by all the Go developers how much better they are, because Rust developers, because
Rust,
they can
yeah.
use WebAssembly. So how come we didn't have WebAssembly before available to us in the Kotlin world? What's the
I think the thing that unblocked it was WASM GC. So in a garbage collected language, you need some support for garbage collection. And this is why I think Rust got to WASM faster, was because it's not GC'd.
reference?
And so they didn't have to worry about
checking.
that piece. But then when WASM GC support was added in Chrome 110-ish, I don't know the Firefox version, that kind of unlocked Kotlin WASM to be able to like be a legitimate option.
Now, how good is that? Like okay, as you know, when we do the GraalVM stuff, both of you know, when we do the GraalVM native image stuff, we say it starts up fast, takes less memory, but the garbage collector isn't yet on par with the JVM's garbage collector. I suspect it'll get there. There's no doubt it'll get there eventually, right? Maybe even sooner rather than later. How good is the garbage collection stuff inside of WebAssembly? If I generate the same amount of garbage I do in my normal.
I think that's a bit different because with WASM GC, the garbage collector is part of the host. So it's not shipped with your program.
Right.
Like in GraalVM, you are basically compiling your application, the libraries, and the GC. And GraalVM has already multiple garbage collectors, so you can choose. Here, the WASM GC proposal is really about providing a structured output that is suitable for modern statically typed languages,
right,
like Kotlin, Dart, Java, etc. And it has nothing about the garbage collection itself. It's the responsibility of the host based on this structure to perform various type of garbage collection. And I can imagine that for server-side workload, we could have some no-op GC, because if you just pop up WASM time, WASM edge, or other runtimes, you just run your workload and you shut down. You don't really care.
Right.
But for some long-running program, you could have various kind of GC, and I think we could even have some pluggable GC architecture where basically you deploy an application, you don't really know. I mean, it's similar to what we have in the GVM, but again, with WASM, the scope is wider because you can go to the browser. You have various other benefits in terms of security. You can basically just also compile native program to that, where the GVM bytecode is really tied to Java. So
right now I can use Kotlin. In theory, WebAssembly can talk to the native operating system specific stuff. You don't have to run WebAssembly in a browser, contrary to the name, right?
No, so WebAssembly is a pure compute engine, and can do nothing.
Right.
Pure WebAssembly. Then you have WASI, you have integration with the JS ecosystem that can allow you to do something, but at the origin, pure WebAssembly workload, the pure WebAssembly module can do nothing, and that's a good thing in terms of security.
Right.
So that's where the ecosystem is currently evolving with WASI Preview 1, which is currently pretty widely used, WASI Preview 2, which is currently rebasing this on top of WebAssembly component model, which is a new library and ultimate component model that is currently developed by the W3C working group and community group. So it's
so if you have a WASM file, if you run that in the browser, it can then it can use the JavaScript bridge to like talk to the DOM and JavaScript APIs, but you can't necessarily do that when you're in a non-browser WASM runtime. But on the non-browser WASM runtimes, you have another option, which is WASI, which allows you to bridge to system calls. And so you're going to want to bridge from your WASM program out to the native platform, whatever that is.
So you could build like
different ways to do that.
GTK and Win32 apps or whatever in 10 years, maybe, or 5 years, or maybe next year, who knows? But I guess my question is, my understanding is that WebAssembly, if it's done correctly, because it's pluggable, because the garbage collector, like you mentioned the JVM, there is actually what is it, Shenandoah? Is that the one where there's like no garbage collection, right? In Java,
I'm not sure if that's that one, but there is a garbage collector where we can basically know.
Yeah, exactly. And that one is great for serverless because you want to start up. Who cares how much garbage you're going to create, because it's just going to respond to a function or something, and then it goes down, right? And then the idea that you have a pluggable garbage collector is kind of interesting in that respect. But what I'm talking about is, let's say I want a stateful sort of process. Maybe it's something that listens for messages in a queue or something using Kotlin and WebAssembly. It's just going to process messages in and out transactional all day long. how, how do we know how good any of these hosts are for garbage collection on that kind of scale? I guess it's.
So I think in the browser, likely they're implementing garbage collection based on the existing JavaScript garbage collector.
Okay. That's really good
Would
then.
be my assumption. The non-browser WASM runtimes, I don't know if any of them have actually implemented the GC part of it yet.
This is work in progress, very early work in progress, but yeah, both WASM Time and WASM Edge have expressed interest into WASM GC, and I've currently I've started or are starting right now supporting WASM GC. And I think what so you asked previously what is preventing wider adoption of Kotlin WASM. So first, it's experimental, and the first usable version was released with Kotlin 1.8.20. So everything is super new. Okay, so it's all about maturity. Okay, so Kotlin WASM is super new. Then you have the GC support in the browser, which is not yet available without a flag. So you need to enable that. There is the origin trial that allow you to enable that for Chrome for specific website. But again, that's super new. Right. So we hope that will be available. So WASM GC is maturing for quite a long time, but I think we are really approaching the point where it will be available without a flag in Chrome and Firefox, and Safari has also started to work on that.
But you see, Edge, how's Microsoft doing on any of this?
Edge is based on Chrome, so I mean not on Chrome, but on the same engine, VIA, etc. So it gets, when Chrome gets the support, Edge gets the support. So no.
When does Chrome get the support? Does it already have it?
It has it via a flag.
With a flag. So yeah, I mean, yes, maybe in a few months we will get it without, but not sure when. But it's approaching the point when we will have that without a flag. And this is super important because for now it's not really usable
for the general public.
For general public. And so we are approaching that for the browser. For the WASM runtime, like WASM Time, WASM Edge, the work has started seriously maybe last month. So we are really at the beginning of that. But I mean, to implement an OP GC, we could have something pretty fast. So I'm not sure. I don't have any. I mean, I'm not working myself on that, but I guess in the upcoming month we will begin to be able to run those workloads. So this is something that is a work in progress. There is also the WASI part, which is an area that is really evolving a lot. So WASI Preview 1 is what is currently supported by the various WASM runtimes. It's a low-level C-style ABI, super low-level. So this is usable, but only for file system, clock, random, etc. No really network support, basic one, but not really usable. What we really want as developers is WASI Preview 2 and upcoming version. Yeah. That will provide network support, HTTP support. It will rebase WASI on top of the WASI component model, which is a very, very clever and nice component model that has been designed for being usable for various languages. So this is all ongoing work. And yeah, I hope that in a few months, those stuff will be stabilized and we will have GC plus WASI Preview 2, be able to create network application and have basically languages like Kotlin, Dart, and other that maybe leverage a bit less JavaScript and target. Basically, we need the two targets. We need to be able to target JavaScript environment for the browser, and we need to target WASI for the server side. So I guess there will be some kind of variant, like you declare if you are building a WASM plus JS program or WASM plus WASI program. Because on the front end, you are interacting with the JavaScript world.
Compilation targets for runtime.
The tricky point is how you achieve to have a consistent ecosystem with not too much split between the two worlds, and that's where there is currently a bit of friction.
Is there when you so I don't have to specify the garbage collection when I compile my WebAssembly code, though. I can plug that in, so it's kind of right. I hate to say this. I hate to say this. It's right once run anywhere in that respect. Yeah. That's the thing I keep hearing people talk about, which is people keep saying this is not just class files from Java. This is containers like Docker. This is the replacement for things. Yeah. Because you can just bring your app and it is truly a universal app. It runs, you need
a runtime.
You need runtime, but again,
there is some similarities with jar files.
Sure, but jar you need a runtime, but that runtime you're not tied to it. I don't need Java's, and apparently you have runtimes everywhere.
It's a bit more complicated than that because so there is a lot of different so there is this JavaScript versus WASI thing where if you are creating a WASM plus WASI file and you want to run it in the browser, you need a kind of shim, a kind of adaptation layer that will work on that depending on the complexity and etc. So that's the first thing. The other point is WASI is not a monolithic thing. There is, I think, 15, 20 ongoing WASI proposal. So WASI socket, WASI CLI, WASI HTTP, WASI file system, WASI clock, etc. WASI SQL. But the higher you go in the stack and the more controversial it is because maybe WASI SQL, you don't have all the SQL operation you want. So for file system, I think for the system stuff, I'm not super worried. I think we will get something pretty usable, and Dan Goman and the team working on that does an amazing job. For the cloud level, it's more controversial because I mean we had some discussion in the WASI bug tracker about what should be the scope of a WASI cloud core. Should it contain SQL or not? Originally, it was containing gRPC. I said maybe we should not put gRPC as a mandatory dependency. Yeah, this kind of discussion where different cloud vendors won't have the same vision of what should be in WASI Cloud Core. And here, I think we need to find a common ground where we can basically. So I think there is an individual proposal, and there is a WASI world, which is basically defining a collection of WASI proposals used together and that are implemented by your runtime. So I think at some point we will have some runtime that will basically implement WASI Cloud Core. And here you will have portability, but maybe your runtime won't implement specific WASI gRPC support, and then you will be only able to run on one and not the other. So, I mean, it's not magic. I mean, I think WASM and the people working on WASI, and I mean, they are doing a great job. But at some point, you have, politics, strategy. You need to make choice, But I think the technical work is pretty great, and they are really listening feedbacks.
So, you mentioned earlier, you can do nothing when you start off with no other things.
No IO, no. I mean,
it's completely isolated like a container, like a Docker image.
Yeah, or like JavaScript without any API.
Right, and so from that perspective, it makes it really secure. You can trust this thing, and because it's really small. You have a runtime that provides some of the bulk, but basically it's just your code. These programs can live in places where it would be very painful, maybe to, like, for example, embed a full JRE or a full .NET runtime or something like that, right? So you could have them in the obvious places are like Lambdas or whatever, but you could also run them in the browser, right? How much we're going to show some WebAssembly in Kotlin. How big was our program?
256K, but your like Hello World one was 11K or something.
Yeah, I mean, there is ongoing big optimization in Kotlin 1.9 done by Zalim and the team, so it's going to be smaller. Yeah.
And that's 250. Basically, you're in a live stream again. Okay. There are images. Individual websites have images that are usually bigger than 256K, right? Yeah. The size is no longer an issue. You can bring Kotlin. You can bring Kotlin code almost into any context. You could even have it like in, I don't know, where would you put it?
The hello world we have with the latest Kotlin 1.9 is 3K basically. So
3K.
Yeah.
That's gives you a lot of options for where you can take this.
Even
as opposed to
public websites. So if you leverage this kind of optimization for server-side workloads, that can be interesting.
Doesn't Kubernetes already have the option to basically deploy a WASM instead of deploying a Docker container?
Yeah, there is some layer of integration. So basically what Docker has integrated as way of running WASI workloads, I think this is Run WASI, or I don't remember the name of the library. You can integrate it. It depends of your Kubernetes distribution, obviously, but there is option to run WASM workloads like you run containers.
That's amazing. And that's today, so we're live at Kotlin Conf. It's 12 April 2023. We should definitely do this again in 6 months. And But okay, so we've
It's
got
all moving really fast, which is
Yeah.
super fast. Because you and I just did this Kotlin WebAssembly thing just came out 1.8.2, right?
20.
Yeah, that was a few weeks ago.
Yeah.
We're very new, right? You and I did a presentation at Devox Belgium. It's weird to say Belgium. I just think of it as Devox, and then there's the other Devox variants that have the extra word. We did that presentation. Couldn't do WebAssembly
No, it
that
wasn't.
easily.
I think there were some experiments, but
Yeah.
WASM GC was really the unblocker for
Yeah.
this.
Uh,
And they cut the Kotlin WASM people rebuilt the back end because initially it was built on LLVM, right? And they then rebuilt the back end to just go direct from Kotlin IR to WASM.
and that's all happened in the last year or whatever.
Yeah.
Yeah. It's
The
Okay.
past few years, yeah.
yeah. So what do you? I already. We're gonna just. He and I are gonna be doing ask our jokes and some nonsense tomorrow. It's gonna be okay. What are you gonna be talking about here?
So tomorrow I have a talk about scaling to zero with either Spring plus GraalVM. So here we will explore the native image support in Spring Boot 3 or Kotlin WASM and explore this new world of basically using Kotlin WASM. So Kotlin WASM is currently targeting the browser. I created an experimental project which is called CoWASM a few months ago now, to be able to basically use Kotlin WASM to create WASM plus WASI server-side application and deploy them in a scale to zero fashion. So this is what I will present tomorrow.
Amazing.
Amazing, yeah, it really is. I don't know. It just seems so. Why would I use? So right now, today is Kotlin JS the better way to go for the browser, or like should we all be moving to WebAssembly? I guess is the question.
Yeah, WASM GC is not available without a flag, so
Yeah.
you need to wait. But I expect Kotlin WASM to be a nice replacement for Kotlin JS in a few years, maybe. It takes a bit of time, but I mean, it could happen pretty shortly as soon as Kotlin WASM mature and as soon as basically WASM GC is available without a flag in the three major browser.
So I did a just really simple test when I first dove into Kotlin WASM to compare performance, and it was by no means like scientific, but I took a Fibonacci program and used Kotlin JS, ran it in Kotlin JS, took the same Fibonacci and did Kotlin WASM. And it ran 3 times faster with and this is all like early days. There's like not even really been optimizations like done to this. And so like the fact that just side by side with no work, no optimization work,
same code,
3 times faster, same code, exact same code.
And there is an aspect that is super interesting is that you can leverage some common tooling. So there is this binarian tooling, which is created by Google. You basically feed it with, so it has a WASM opt executable. You feed it with a totally unoptimized WASM file. And basically, I think the Kotlin WASM did not spend too much time on crazy optimization because you provide this big and slow WASM file. You process it with binarian, and the output is 10 times smaller, 10 times faster. And that works with any language. It supports WASM GC. So this is a nice thing. I mean, Oracle has put a lot of energy to optimize JVM, and that works for Kotlin JVM and Java, etc. Here, the optimization that Google spent crazy amount of time working on binarian, it works for any language. So for Kotlin, for Dart, for Rust, you basically use the same optimization toolchain, and you can basically avoid to spend this time of engineering for each language. So I think that's a game changer.
Because you're doing it on the Kotlin, you're doing it on the WebAssembly code.
Yeah.
It's just it's like that. What's that thing we use in GraalVM to prune UPX? Is it?
UPX is more pure compression, so it's pure compression, but GraalVM itself is doing the optimization for that.
Yeah, so because the WASM is just this, like, I don't know, IR of
course,
some representation of running things.
Right.
And so of course you could unravel that and optimize hot loops, do whatever, right? Like, or tight loops. And so I think that what's really interesting is that this is kind of the first time that we've had a portable bytecode that is agnostic to the underlying architecture,
right,
and platform. And so
besides Java,
I mean, Jar,
I mean, the browser is not accessible. I mean, plugins are dead, applet are dead.
Yeah.
And so,
I know what you're saying. Yeah.
GVM bytecode remains specific, close to Java. I mean,
Yeah.
Kotlin was able to adapt because it is close to Java semantics.
Sure.
But I mean, for Rust, for C, GVM is not useful.
Yeah.
If you want to target the browser, it's not useful. GVM has access to all the file system, etc. So it's not designed like Node.js or the browser where you have a pure compute unit, and then you can carefully give some write, etc. And we have not talked about capability-based security, which is another topic, but maybe not for today. So yeah, you could have the impression that it's another bytecode like the GVM. In practice, it shares a lot of common characteristic, but it's
I
much
think the
more
biggest difference is that in Java bytecode and class files, they're really modeled after the Java sources, right? Whereas bytecode for WASM is really modeled after the like execution primitives that you want to actually run on the CPU.
Yeah.
Right.
And so, so I think it's totally a different way to look at it. I think the most similar thing is LLVM bitcode.
Yeah, it's a roll level.
Except the LLVM bitcode is architecture dependent, right? So it's not portable like WASM is.
And except you can compile pretty fast WebAssembly bytecode where LLVM is notoriously slow for various reasons.
Which, speaking of slow compilation, recently GraalVM added support for RISC, RISC as a target. And there's a line at the very bottom of that, this release announcement saying, this work done to make RISC a target for GraalVM native images could, in theory, bear fruit one day in the far future for something like WebAssembly. Okay. And now, do you know anything about that? Do we have any ideas on whether GraalVM is actually working on WebAssembly or something, or like, because that would be interesting too, is if you could take your GraalVM native image, and that also, there's truffle VM, so you can get a lot of things to go to native image. It's not as good.
It's different based. GraalVM is based on LLVM, etc. So,
which also has
but it may be interested. They work on that, but I have no information on that.
And I know LLVM has a WebAssembly. I mean, that's how the WebAssembly.
Yeah, but it's so LLVM is slow. LLVM is not really the right toolchain to target WASM-GC. It's more to target WASM plus linear memory. So I don't think using LLVM for modern statically typed languages is a good idea, and that's why Kotlin stopped to use Kotlin native with the LLVM toolchain and just created its own optimized WASM-GC toolchain, and then use binarian to optimize that. It's a different
paradigm. Amazing. Anything else we should add? Oh, by the way, there's some questions here. First of all, Ambu says hello to the Greek hero. That one right there. Did you see the blog yesterday?
Yeah.
Somebody described him as working like a Greek hero, which is epic. It's mythic in its semantics. Abel from all sorts of cool stuff. He says, greetings, High Spring champions from let me see, I'm gonna put these up there. High Spring champion says Khaled. Hi buddy, good to see you. Salut, Sébastien represent. Yep, that's true. You're welcome. No problem. Thanks to these two for joining us. I think an interesting analogy is using LLVM for compilation. Did we just talk about that? I'm not sure if I think I brought that up and then I got dismissed. Is that right? It is interesting. Epic to see three gurus. There's two, and then there's me. There's a difference. I have the coffee though, so
Okay.
Good. Anything else before we have?
We should say that our talk is going to be live streamed. Well, all of our talks are going to be live streamed. Tomorrow.
Kotlin Conf. Is it free? Do you have to have a ticket or something?
I don't know.
I think that's free.
I don't know.
Why if it's live stream? Why don't we just do it from home? Why do we have to?
Because we are in a pretty nice venue.
We're in the nicest venue. This is the speaker room. Don't tell anybody. Look at this place.
Tour.
Look at this place, people. This is the speaker room. Trust me, most of us haven't ever been in a room like this. And that outside is, I'm not sure if you can see it because this laptop camera is pretty crap, but that's Amsterdam. It's beautiful.
So that's why.
Yes. Oh, yeah. Okay, yeah. So join. I guess you go to kotlinconf.com or something.
Yeah, and they will put a link. I think.
Oh, good. When is your presentation?
Tomorrow afternoon. I don't remember exactly. Around 4 p.m., but I don't remember exactly.
Amsterdam time. So if you're not in Western Europe, then make sure you do the delta there. And ours is like 11. in the morning.
Yeah.
Uh,
Amsterdam time.
yeah. So, okay, good. Everybody, thanks for hanging out. We have to go get, I'm sure they have sandwiches and absinthe or something. I don't know. What do they, it's the Netherlands. It's probably going to be great. Bye, everybody. Thanks for joining me, gentlemen.
Bye.